All right, welcome to the next set of notes. Before we get started on notes today, I wanted to pretend like we're in class and I would answer questions based on some of the questions I saw today. So I just wanted to reteach really fast. So hopefully it won't take but a minute or two. I wanted to remind you, this is a cubic function. Like this is y equals x cubed. I found some pipe cleaners. Okay, so here is a transformation. Here's an equation. So based on some of the questions I was getting, I want to make sure you guys are doing it the same way before you guys submit it and turn it in. So there's transformations taking place here. This is of 7 because it's outside of the cube. This right here is left or right, remember? So you would say 3x minus 4 equals 0. So it's x equals 4/3, so it's going right 4/3. Then there's no negative here, and there's no negative right there, so there's no reflection. But how much is it stretching and compressing? So the 2's out here, so that means it's going to go a vertical stretch. So it's going to stretch away from the x-axis. So it's going to get taller, thinner, I guess, more narrow. But then at the same time, that's a horizontal compression of 1/3, which means it's pressing towards the y-axis because that's compared to the y-axis. So it's getting further. So it's kind of weird. So instead of doing a vertical and a horizontal, remember in the notes I said it's 2 going to be 3 cubed x cubed. Find the first term. So 27 x cubed times 2. So what is that? 54 x cubed? Oh, I can't see. Sorry. So 54 x cubed. So that would be a vertical stretch of 54 x cubed, which didn't make sense because a second ago I was like, here it is. It stretches away from the x-axis and then it presses toward the y-axis. So it got further. The shape got kind of skewed looking. So instead of doing that, we just do one overall transformation like that. So make sure your homework reflects that. Go back and check that out. So I don't want to. Since I have my little shape here, it's kind of cool. Here's y equals x cubed. And if you just turn it sideways, here's y equals cube root of x. It's the same shape. Also a reminder, here's y equals x cubed. If I reflect it over the x, it means I pick it up and go that way. That's y equals x cubed. But then notice this. If I go reflect over the y-axis, I pick it up and go this way, and it's the same graph. That's why we say that it didn't matter if it was reflect x, reflect y, and that's why when I expanded it and the negative came outside, that's why it did matter. But I want you to say y equals, you could say it reflects over the x or the y, but if it's outside, it's reflect over the x. So you can see this shape is symmetrical with the origin. Okay, that's a little rundown. All right, so now you need to get out your Springboard book. So I'll have to pause the video and go find your Springboard book. It's been quite a while. So Springboard book, I thought we could go a little faster if we have the book. We just highlight some things in here because a lot of this is review. So hopefully we can go kind of quick. So 26.1, square root functions and regressions. So take a moment, pause the video, go find your Springboard book. All right, so now let's get back at it. First thing I want to talk about is let's review this. X to the 2/3 power. That's called a rational exponent. Remember, this is power over root. So it's to the second power and the third root. So another way that you can write that would be cube root of x squared. Or you could say it like this. You could say cube root of x squared. These are all equivalent statements, actually. So all three of these are the same thing. So just a little review of a rational exponent or a radical. And these are equivalent as well. That's what this is right here. It says a to the one end. There's the little box that Springboard has. So you can use that as a guide if you like. Okay, then we're just kind of quickly going to go through this because this is review. Let me get a highlighter. Okay, so then here it's saying graph y equals 1x to the 1/2 power, which you guys know that's the same thing as what? Y equals square root of x. And that's what this graph is right there. That's f. Then it says, and it told you to plot some points. I did it for you. Let's move on. Then it tells you to interchange x and y. So you guys already know How do you find the inverse? Switch x and y, solve for y. So here is the inverse of it. And the one characteristic of inverse functions, hopefully you can tell by looking at the graph, is what? Okay, great. So it reflects over the line y equals x. Remember inverse functions, if they're inverse of each other, you can tell graphically to see if they reflect over the line y equals x. Okay, let's keep moving. This should be a review for you. So it says the graph, their inverse is the domain of both of the functions, and the inverse is x is greater than or equal to 0. The range of both, okay, well that doesn't really help us much, but we can tell by looking at the graph. Then it tells algebraically, so you need to be able to do both. So algebraically, and I know you guys know how to do this, so I'm not going to go too slow. So how to find algebraically, you can see here's the function, switch x and y, solve for y. So like here's the original, here's the inverse. But you guys already knew that. You guys knew that the inverse of a quadratic is a square root, right? Quadratic and square root are inverses of each other, right? Let's move on. One page down. All right. Hopefully everybody has that. Any questions? Come call me on video chat. Okay. Now let's do this one. Graph the function x minus 3 to the 1/2 power, which is the same thing as the square root of x minus 3, right? So let's do that. So y equals, some of you might do this, which is totally fine. You might rewrite it like that because it's a little easier to understand. Okay, so then I use pencil. Then let's come up with some points. So I'm trying to think of some points where I can take the square root. So if I plug in 3 minus 3 is 0. Then square root of 0 is 0. If I plug in 4 minus 3 is 1. Square root of 1 is 1. Plug in 7 minus 3 is 4. Square root of 4 is 2. Plug in, what's another one we can do? Plug in 12. 12 minus 3 is 9. Square root of 9 is 3. Okay, so here are some good points for this, so we can graph it. So let's graph it. So 3, 0, 4, 1, 7, 2, 12, 1, 3. Okay, so here is, oh, missed a point. Sorry about that. All right, so here's f of x. Then it says to do it. Then it graph its inverse. So instead of solving for x and y and all that good stuff, let's just do it really quickly that you guys know. So what's a really fast way to graph this without doing algebra? Okay, great. I would just switch x and y too. So the inverse function, just switch x and y. So let's do that really fast. You would just say 0, 3, right? Then we say 1, 4, 2, 7, 3, 12. So I just flipped x and y because that's what inverse does. So then let's graph that. So we should know it's going to look like it reflects over the line y equals x. So 0, 3, 1, 4, 2, 7, 3, 12. And one thing you do need to make sure it keeps the same shape, right? Sometimes I saw that before that you guys would not keep the same shape. You would plot the points and kind of the shape would kind of change, but don't do that. Like if this is a square root function, it's just turned. All right. Then hopefully you can tell. I'm just going to go like this. I can tell it's reflective of line y equals x. So they're inverses of each other. So yay. Okay, let's keep moving. For the function in part A, do it algebraically. Okay, so let's do that then. Now let's do what they ask. Y equals the square root of x minus 3. How do you find the inverse algebraically? Switch x and y. So x equals square root of y minus 3. Now let's just solve for y. So first thing we do is the radicals by itself. We've learned that already. How do you get rid of the square root? Square both sides. So x squared equals y minus 3. So x squared plus 3 equals y. Okay, let's take a moment and think about this, what I just said a second ago. So if this is the original function, the inverse has to have the same shape, right? And that's what we did here by switching x and y. So this looks good. But when you do it algebraically, I'm going to draw a pen. We know this is a square root function, and we know it's going to look like this, right? Well, if you graph this function, what does this make? This is going to make a what? A u. They're not the same shape. What are we going to do now? So what do we need to do? So this shape and this shape have to be the same shape. So there's too much going on here. So we're going to have to restrict the domain. So let's do that. So how would you do that? So what part of this parabola do we want to match this part? Okay, if you're not sure, let's do this then. So over here, what would it be? What's the domain over here? And the range. The range here is what? Let's do the range. Is y is greater than or equal to 0, right? So if this is the range of this one, then what has to be true of the inverse over there? So the range of this one is y is greater than or equal to 0. So that's the range. Then the domain here has to be what? X is greater than or equal to 0. So that is the restriction. So this all should go together right here like this. So that would be our restriction. So it says it right here. Keep reading. The domain of the inverse should be restricted to match the range of the original. And that's what we just did. So I'm going to say that again. So you can tell this is why we're doing it, because this is a square root, looks like this. Well, when you do the inverse, you got a quadratic, which looks like this. And we said in the beginning, like they have to have the same shape. Well, they don't. So that means we have too much here. So let's gonna restrict it and just take half of it like that, or take half, like x is greater to 0. Then that shape does match that shape. So when you're working with square roots and quadratics, you have to restrict the domain. So make sure you pay attention to that. Okay, let's keep moving. This is complete this statement about the inverse. The inverse is what? Y equals x squared for x is greater than or equal to 0. All right, let's do another one. How about, let's write this out. Everyone write this out. So the inverse, this is important. The inverse of a square root is a quadratic with a restriction on the domain. Super, super important. You will use this in pre-cal for sure. So the inverse of a square root is a quadratic with a restriction on the domain. Highlight, circle, bubble, whatever. You need to remember that because you will use that in pre-cal again. Let's see. Do we want to do number 2? Find the inverse of the function, blah, blah. I guess we could do it really fast. So find the inverse of this. How do you find the inverse? You switch x and y. I'm going to do it fast. And solve for y. Okay, so first thing I would do is want to solve for y, gotta get rid of that 1.34. So x over 1.34 equals y to the 1/2. Well, y to the 1/2 is the same thing as square root, right? So we've already learned, like, how do you get rid of the 1/2 power? You raise it to the power of 2, right? So it's going to be x squared, or x over 1.34 squared equals y. And I would simplify that, but I have a calculator, but let's keep moving. You guys get the idea. So we could square it if you want to. All right, let's keep moving on. Next page, last page, I believe. Okay, it says, let's do the same for a square root function. Okay, so here, let's keep on. Okay, so it says, physics class conducted an experiment comparing the period of a pendulum to the length of a pendulum. The results of the experiments are given in the table here. So it wants us to graph this really quickly. So let's do that. It's going to take a second. So I'm going to try to go as fast as I can. So it's going to be 6.8. I'm going to go fast. 6. 10. 1. 14. That one is too high. 2, it's like 2, 3, 4, 1, 2, 3. Yeah, it's even off. I love when Springboard does stuff like this. It's my favorite. 18, 1.35. And then 22, 1.5 up here. I don't know, something like this. So now the graph is going to look something like that is what we're thinking. Okay, so I'm not really sure what this graph is, but then it says make a scatter plot. What parent function does the path follow? I'm not really sure. So this is what we're going to do now. We're going to pick up a calculator. So hopefully you have a calculator in your hand. If not, stop your video, go get a calculator, get Desmos, or whatever you're using. Cool thing is, that's why I wanted Springboard book today, is that if you need to follow the instructions, they are on the back right here. So if you need to refresh yourself on how to use a calculator and do stat, edit, all that good stuff, here is the instructions. So very quickly, together, let's type in stat, list 1, list 2, so it'd be what, 6, 10, 14, 18, 4, I'll try to go fast. 1, 1.2, 1.35, 1.5. Cool thing is that you can stop the video and take your time on this. Okay, so I'm going to go graph. I clear out. I already have something else in there, so I'm going to clear that out really fast. So you're probably like, why is it not showing up? It's not showing up because my scatter plot's not on. So second y equals, turn the scatter plot on. I see it there, but I don't see a lot of it. Why don't I see a lot of it? Because what is, let's see, how come I'm not seeing the window? So let's check it out. Stat. So we need to make it what? X max will be, I don't know, 40? Let's do that. Oh, okay, there's the graph. So I changed my window. Now I can see it. So there's kind of the scatter plot I have in my paper. We'll then go to stat calc, and it tells you on the back. I'm going to highlight that for you really quickly. It tells you is power regression, and then it says power regression stands for power regression for any regression. So anything that has a power. Anything that has a power, use power regression. X squared, x cubed, x to the 1/2, x to the 1/4. Like anything that has a power, use power regression. And that will help you. So let's do that. Stat. And then power regression is A. There is my information. So it tells you it is y equals ax to the b. Tells you A is 0.33, B is 0.488 is what I got. All right. So then if I write that down, it'll be what y equals 0.33x to the 0.4, we'll say 49. Okay. Now look at this power. That power looks like what? What does that power look like to you? Well, that's power of 0.5. That looks really close to y equals x 0.5 to the 1/2. So that tells me this is what kind of function. This is a square root function. It says what is the parent function of the path that you think this follows? This looks like a square root because the power regression gave me 0.49. So I would say y equals square root. Okay. Well, not only is it square root, what did the graph do? 0.33. So the graph shrunk, right? Sounds weird. So it's like a vertical compression, vertical shrink, because if A is between 1 and 0, it's a vertical compression, right? If that would have been greater than 1, then it'd be a vertical stretch. So the regression can tell me if it stretches or compresses, and then 0.5. So if you were to compare this really fast, this is really weird. It's being bored. This graph is horrible. 0, 0, 1, 1, and then 4, 2. So it's crazy. But this is the parent function right here that I just drew really fast. Because you can look at the numbers 1 and 2. So here's the parent function. Well, yeah, you can tell like it really got pressed. If it's a vertical compression, it got closer to the x-axis. So you can see that pretty plainly. Okay, so the biggest thing here is knowing how to use quadratic regression. I'm sorry, power regression. I apologize. Power regression. Here are all the steps. So hopefully you do have your Springboard book with you. And it even tells you right here what the answer was. So you could check it if you like. And I think I'm going to stop there because I think you guys can follow that. If you have more questions, I don't have any more examples. Just see the next assignment for your homework. So if you need help, give me a call back. And you guys are doing awesome. Almost everybody turned their homework in on time yesterday, which is really great. So if you haven't turned in your homework, please do so. The answers are posted. So go check your answers and let me know if you guys need help. All right, talk to you later. Bye.